Hello, everyone. Welcome to another edition of Thai Conversations with Ida Padikuor Na-Tei. Thai simply means technology, innovation, and entrepreneurship. And we basically talk to tech innovators and entrepreneurs in the diaspora and on the African continent. Today, I'll be talking to a very, very good friend who happens to be a robotics engineer in University of Michigan. Thank you so much, Alphonsus, for joining us today.
Hi, Padikuor.
Okay, this is the first time someone has actually called me Padikuor on set. How are you?
I'm good. I'm feeling great.
Okay.
It's a good morning.
I can see that. Okay, so let's just get right into the questions. So, a little bit about yourself and what you do.
Obviously, I'm Alphonsus and I'm currently a robotics PhD student at the Robotics Institute in University of Michigan. And my research mainly focuses on optimal control and planning to enable robots to perform long horizon complex tasks in real world environments. And I obviously like building robots and like getting robots to work in the real world. And one of my main reasons for being interested in robotics is that robotics enables you to basically manipulate the world and make the world look just how you'd want it to in a physical sense. And personally, I am very I'm a control freak, so I like to control my environment and ensure that everything is the way I want it to be. And I realize that robotics is the career that basically gives me the license to do that without anyone questioning my sanity. So that's like one of the main reasons why I'm in robotics. Yeah.
So you've done lots of works on robots. And I believe you've done more than 4 years of working as a robotics engineer or working on robots. So I want to know how your journey has been so far.
Yeah, so the first time I actually encountered robots was, I think, back when I was about 6 years old. They used to show these really cool Indian action movies on TV3. And there was this movie where there was the protagonist was like, he set up a system of like catapults and basically continuous motion systems that basically connected with each other and worked with each other to kill the villain. And I thought that was very, very cool. And so I actually tried to build something like that in my house, and to just hit my siblings, and that was fun. I got into trouble with that, but yeah, I'm still here. So yeah, so after that movie, I realized that I was really interested in getting things to move on their own and basically controlling things. And so I mostly fidgeted with tools and toys of my younger siblings. And so they used to get lots of remote control toys and like those remote control toys that have motors that can control them with radio signals. So I used to take them apart and basically just to figure out how they work and to basically understand them, because I was always driven by this need to understand how physical systems work and how I can get them to do what I want it to do. Because in order to get something to do what you want it to do, you basically have to understand the underlying model that drives that system. And so that was my main drive. I just wanted to understand things. And so I realized that if that's what makes me really interested in things, like I might as well just translate it into a career.
Okay.
And so along the years, I think in 2008, I watched this cartoon which was called, I think, Meet the Robinsons. And so Robinson was this young boy who lived in an orphanage who was really cool at building cool things. And once I watched that cartoon, and I think his future self traveled back in time to remind his younger self not to give up or something. And that was the whole moral behind that story. But what interested me most was basically how this future self like started a whole company with a bunch of robots, where he built a robot battler as well as like some other robots, and basically built an empire which was made up of robots and machinery. And I thought that was really cool, and that's basically inspired a zeal in me to become like him for some reason. So I found that really interesting. And then I also watched Iron Man. I think the first.
I'm expecting to hear about Transformers, but you haven't mentioned Transformers. But
I don't know. Transformers was a bit creepy, but I don't know, because in Transformers there were no humans building the robots. I think what was most interested in me, what I found most interesting was basically watching humans build the robots, because in Transformers the robots were already existing, and so I didn't think that was really cool. Like the human aspect of like human building the robots was what I found really interesting. So in Iron Man, what made me really interesting in Iron Man was like, I think in the first scene when he was captured by those Siberian rebels, I don't know, he built like a robot suit in a cave, and he got out and killed all the villains. I thought that was really cool, and Iron Man was like the pinnacle of my interest in robotics, and I definitely wanted to be like him because I thought it was really cool.
Okay. All right. So I've seen a lot of your works. I've been following you. I've been seeing your projects, and I know you do a lot when it comes to assistive humanoid robots, right? So tell us about some of the projects you've worked on personally.
First of all, I applied to Tufts University because of a specific professor. He was got a Professor William Messner. I mainly knew him because I used to watch lots of YouTube videos about robotics, and I watched an interview on YouTube where he was talking about self-driving cars, and it made me really interested in his research. And so I emailed him and told him, hey, Professor Messner, I watched this video, it was really cool, I'm really interested in your work, and he encouraged me to apply to Tufts University. And so I did apply, and I got in, thankfully, and I moved to Boston to start my undergrad education. And I met him and told him I was really interested in his research, and he invited me to join his lab. And so around the time, luckily, he won a grant to work on a robotics project that involved building robots to assist the elderly and people with spinal injuries to perform domestic chores like cleaning, cooking, and washing, and all of that stuff that regular humans cannot perform. And the main reason is that people with spinal injuries, especially when they are injured at the C4 or C5 region of the spinal cord, that's the cervical vertebrae region, because the spinal cord is responsible for sending signals from the brain to all the other parts of the lower body. If you're injured at the high regions of the spinal cord, you wouldn't be able to control your arms and your legs. And so they're mostly paralyzed from the waist downwards. And so they have no ability to control their legs because the connection from their brain to their legs is severed. And so for such people, they are rendered incapable of walking. And so they are mostly stuck in wheelchairs, and they have to rely on attendants or other people to help them to do regular things in their homes, like cleaning, cooking, and even bathing them and feeding them. So they are like totally reliant on people. And so this grant was focused on, with this grant we are supposed to build robotic systems, that's basically robots and tools, to enable such people to be able to perform these kinds of household chores on their own. And so since I started working with the professor, he invited me to join this project, and I was more than willing to join because I was filled with enthusiasm and zeal to build robots. And so that's when I started working on this project. And yeah, so when we started, my main task was to build we were already given this bimanual robot. So a bimanual robot is a robot with 2 arms. And that's the Baxter robot. It's a very huge red robot. And we're given that robot and we're supposed to basically get it to move around because the robot itself was built to be static on a pedestal. And because it's static, it's not going to be able to move around and interact with objects. And so my main task was to build a mobile system on which we can mount this robot in order to get it to move around and interact with objects in the kitchen. And so that's what I worked on. We converted an electric wheelchair into a mobile robot base. So I basically just
before we get into that, so I saw 2 major projects that you worked on. I know you worked on many others, but I'm going to start with the red assistive humanoid robots that you worked on. Now, I realized that it's able to respond to voice control, is able to help with picking up of objects and all of that. Can you tell us a little bit more about that particular project and how long it took you to actually finish it?
Oh yeah, so with that project, once I joined Professor Messner's lab, he won a grant to work on building this a robot that can help people with spinal injuries and elderly people to perform household chores. And for people with spinal injuries, they are unable to usually walk because once you are injured at the cervical vertebrae, that's the C4 to C5 region of your cervical vertebrae on the spinal cord, it cuts off the ability of your brain to control the lower parts of your body. Because the spinal cord is responsible for sending signals and commands from the brain to the other parts of the body. And so once those regions are damaged, the brain is not able to control those parts of the body. And so such people are unable to actually move their legs or send electrical impulses to the muscles in their legs to move. So as a result, they are mostly rendered incapable of walking and are stuck in wheelchairs. And they usually rely on people to feed them, to even bathe them and cook for them.
So this robot is supposed to replace the humans who were supposed to perform those tasks.
Yeah. Basically, that was the goal, because it's you imagine if you are stuck in a wheelchair and you have to rely on a human being to like bathe you and feed you and clothe you and all this stuff. Like, even though it might feel nice at some point, like you still feel a bit ashamed because you essentially don't have control over your life. Someone else is rather doing everything that makes you a human being, and it's not really a nice feeling to have. And so the aim of the project was to build robotic systems that can replace these humans in performing these kinds of tasks. So that was the main goal for this project. And with regards to my specific duties in this project, the robots we got to work with was the Baxter humanoid robot. So the Baxter humanoid robot is a huge red robot that is mounted on a pedestal, a static pedestal. And so the robot itself was not built to move around, but in order to perform these household chores, we need the robot to move around and interact with objects around the house, around the apartment. And so my main task was to build a mobile platform, or that's a movable robot base on which we can mount this red robot on to enable it to move around. And so that was my main project. And so when we began, we deliberated on the different kinds of mobile robots we could actually use, and we settled on an electric wheelchair, because the benefits of an electric wheelchair is that it's built to support a lot of weight, because it's built to support human beings, and so it's very rugged in its build, and also it's electric, and so you could basically control it with electrical signals from, say, a computer. And so my first task was to basically convert this electric wheelchair into a mobile robot base. And so what I basically did was I stripped off the seats and basically took off everything that makes it a wheelchair and just left the bare bones electrical motors connected to the two rooms at the bottom. And I hacked into the control systems of that electric wheelchair to enable me to control it instead with my own microcomputer, like a Raspberry Pi or something smaller.
Okay.
So once I got that working, I built the software system to integrate the mobile base with the humanoid, the humanoid with its bimanual arms. And once we got the whole system functioning, we then programmed in tasks that can enable you to perform like some household chores, like opening a fridge and picking up objects and obeying voice commands. And
okay, so how long did it take you? How long did it take you to complete this particular project?
And so we started I joined the lab in 2017, and so I worked on it from the summer of 2017 and we ended the project in the summer of 2019. So roughly about 2 years.
I was in Boston.
Yeah, that was in Boston. In our lab in Boston.
Okay, so how long? Okay, you already told us that. Can you give us in months how long it took you? I think you didn't finish that. I wanted to, yeah.
Oh yeah, so in months. So I started in the summer of 2017. So from, say, when you start from June till June all the way to December, it's probably 6 months. And so probably about 45 to 48 months in total.
But you had some breaks.
Span 2 years, but excuse me.
You had some breaks in between, like it wasn't a continuous.
Oh yeah, of course, because I was also a student, so I had to go to class and pay attention to the teacher and do exams and all that.
Okay, so talking about you being a student, I have a question on that, but I want us to take a break and watch one of Alphonsus's projects. I think we're going to watch the red assistive robot.
Pick up objects.
Okay, so we are back. So I'm going to talk about his life as a student. I know that in your undergrad, you studied mechanical engineering and computer science. Now, I want to know that were those courses relevant to your journey as a robotics engineer? And what balance do you need when you are using both? Because I know you need mechanical engineering and robotics, and you need computer science because you need to program the robot. So which one plays more? Or do you think they are both at the same level? And do you need both to be able to be a robotics engineer?
Yeah, that's a good question, and that's a question I'm only now realizing the answer to. So initially, I started as a mechanical engineer because I was very interested in physical systems, but then I soon realized that in order to control physical systems, you need some level of competence in computer science, be able to program and understand how to write programs for robots. And so I double majored in computer science as well. And throughout my education, sadly, the Taft's mechanical engineering program was not that focused on robotics. It was mostly focused on like thermodynamics and fluid mechanics and all those classic archaic mechanical engineering stuff. And so my education in computer science was probably much more relevant to the work I did in robotics than in mechanical engineering. I think the only course in mechanical engineering that really had any effect on my robotics education was a control systems course I took. But then other than that, all the other courses I took in computer science were much more relevant. So I'd say for now, if you're interested in getting into robotics, I think a computer science degree is much more relevant to robotics than just a basic mechanical engineering degree. Because mostly, most of the stuff you do in robotics would mainly be programming physical systems. Because most of the physical systems, all you need to do is basically to understand the basics involving the mechanics and the dynamics of the physical systems. And this would just cover like a couple of courses in mechanical engineering. That's basically mechanics and dynamics and also statics. And so once you have all those grounded, everything else is just computer science. And so I think a computer science degree is definitely much more helpful towards a career in robotics. And mostly in robotics research, we don't necessarily build our robots ourselves. We mainly use robots that are built by companies, and all we do is like write algorithms on such robots to get them to do cool stuff. And so most of the algorithm writing,
like the way to say we program them to do cool stuff. I'm just kidding. Let's continue.
Yeah, because it's so most of the programming and all of that stuff is mainly in computer science and in artificial intelligence. And so I think a degree in computer science is definitely going to help much, even though you still need to know the basics of Lagrangian mechanics and your classical equals ME and all that stuff. But then those are all fundamental knowledge you could get by just taking a couple of courses. But then in mechanical engineering, but then computer science is basically very important, because all your code is going to be running on the processor, which is going to be built from ground up to be optimized for your specific purpose. And by taking a degree in computer science, you basically be learning exactly how this processor is built and how to write fast and efficient programs for these processors. And so having that degree in computer science will really help you more.
Okay, so I saw another project that you worked on. It was it looked like a cart. It didn't really have a body of a sort, but it was like a robot, and it could respond to instructions. Can you tell us a little bit briefly about that particular project?
Oh yeah, so it's spun off from the robots with the Baxter robots. That's the big red robots. And the reason why we started working on the cat is that, first of all, the Baxter robots cost almost about $60,000. And we imagine that if we were to actually build a robot for people to use in their homes, people are not going to spend that much money on just a single robot. And so we had to focus on what do we really need the robot? What do we really need from the robots? Do we just need a big fancy robot, or do we need something that's useful and that can perform tasks we want it to perform? And so because of that, we started thinking of a smaller form factors, because the Baxter robot was like extremely huge and it's probably not going to fit into the doorway of a regular apartment. And so we started thinking of what are the key simple things we actually need in order to get a robot to function in a real world. And so we started thinking of like, which kind of platform should we use? And so my advisor went shopping in a mall some time ago, and he was using a shopping cart, and realized that this shopping cart was like very robust and strong, because it's built to withstand lots of load, carry lots of items from the mall and all that stuff. And so he thought of it as like the optimal robotics platform, at least for research, because it's strong, it can withstand a lot of weight, and it's also very light. And so even if it crashes on you, if it crashes you or it crashes some item in your house, it's not gonna break or it's not gonna cause that much damage. But then with the Baxter robot, it's like 300 pounds, and so if it crashes you, you're probably gonna get hurt or die or something. So the shopping cart was like the optimal platform. And so what we had to do next was basically to build in the various things we need for converting the shopping cart into an actual robot that can do things in the home. And so we built a cylindrical manipulator, which basically worked in cylindrical coordinates to basically grasp objects. And that was like the most minimal robotic manipulator we could build on top of it.
Awesome.
As well as
So yeah, that's awesome. So you're gonna watch a short video on that particular project. I know you're also working on a very, very advanced robot currently, which is even more advanced than these ones. Hopefully we might be able to show a few snippets of that. If not, you can always contact Alphonsus through us. And I'd like to ask you, when we come back, I'm going to ask you about let's just watch this video and come back. Hello, everyone. Welcome back. So we are continuing with our discussion with Alphonsus Edubedu. He happens to be a robotics engineer at the University of Michigan. So Alphonsus, so I've had this thought, and it keeps bothering me because I watch humanoid robots performing tasks, and they are extremely slow. Like I really do a lot of things at the same time, and I like to have my things done very quickly. Right. And I watch these robots and it's like they have to perform, they have to pick up a button and it takes like forever. Like I know it's like just 20 seconds, but it feels like forever to me. Why are robots that slow in performing tasks, and what can be done to speed up their speed and probably efficiency?
Yeah, so that's a great question. And the main reasons why these robots are very conservative in their gaits or slow is that there are probably three main reasons. The first reason is mainly with regards to the hardware themselves. So these hardware are built like are custom made, and they are also very expensive. And so if you act very quickly, you might end up breaking a gear or some pivots or some parts in joints that would probably cost a lot of money to fix. And so these kind of robots end up being very conservative in their movements. And the second is a more technical problem, which it deals with basically how the whole control system is formulated. And so they are mostly built so the current control systems are try to cancel out the whole dynamics of the system. It could get a bit technical, but then what they're trying to do is basically, because in order to control the system, instead of taking advantage of the dynamics and basically molding the phase diagram in order to get the robot to do what they want to do, like instead of like it's kind of like
I can see you're trying to simplify it, but then it's not working. Okay.
Yeah, let's try this. So, for instance, if you are swimming in a sea, and the sea has a bunch of waves, like the sea is a bit turbulent and there's lots of waves. What you could do is, if you swim against the current, you realize that there's going to be a lot of friction on you, because you have to exert a lot of energy to first cancel out the reactive forces from the waves that are acting on you, as well as enough energy to actually move yourself forward. And so in current robots, that's what you're trying to do. You're trying to exert enough energy to cancel out the dynamics of the robot system as well as exert just enough to actually get it to, say, move the legs around. And that's what the current algorithms allow the robots to do. And that is not very efficient, because you realize that you end up spending a lot of energy and you end up working very slowly, and you wouldn't be able to actually do more things than you want to do. But then another way to look at it is that instead of fighting against the currents, you should rather like swim along the current. So instead of going against the current, instead of that, you could rather swim along the current and let the currents take you. And by letting the current take you, all you need to do is basically just curl your arms in very small. You wouldn't need that much energy to cancel the current, because the current will be taking you along. And so all you need to do is just basically specify your direction with your arms, and that will help you to move smoothly and much more fine. And that's what we're trying to do with current robotics research. And this field is basically under actuated robots, how to get under actuated robots to take advantage of the dynamics of their system. So current algorithms are unable to do that in most cases. I think the most advanced robots are the Boston Dynamics robots that try to do that of some sort. But then even with those, there are lots of error cases, and it's not that it doesn't work that well. And so that's an active field of research in robotics. Okay. That's basically how to exploit the dynamics of the systems in order to get it to work. And I think the third reason why robots are slow is that so the first was hardware, the second was the algorithms are not mature enough, and and the third reason why robots are that slow is mostly as the cost as well. As I think it's basically just like the first point. The cost, they are very expensive, and so you wouldn't want to like run them very quickly, else they might end up getting damaged. And because the algorithms are very slow, they wouldn't be able to react in time to very high frequency actions. And so you need to make the robot's gaits as slow as possible in order for the brain of the robot to catch up. So the robot is basically dumb and it doesn't think very fast. So you want to get the motions to sync with the processing power of the robot's brain, so to speak.
All right. So now let's move to Africa, right? How can Africans inculcate humanoid robots or robotics engineering in our sectors to cause economic development?
Yeah, so that's something I've been thinking about a lot of late, because as you enhance production in our industries, and I don't think we would necessarily need humanoid robots, because humanoid robots are usually scary, and humans are not the most efficient systems. If you actually think about it, humans are very inefficient mechanical when you think about it mechanically, because walking stably alone, it takes up a lot of energy. It would probably be more efficient if we're working on 4 legs, because by working on 4 legs, you have multiple points of contact on the ground, and so your system is much more stable, and because your center of gravity is much lower, you would basically be much more stable than basically working on 2 legs. And so humans are very inefficient mechanical systems, but I think so. My main suspicion is that we evolved to have like bimanual arms and legs, mainly because of to enhance reproduction. That's probably like the main reason why we work on 2 legs, just to make reproduction much easier. And so coming back to your question, how can robots help in the development of workers? So one of the major things that inhibits the development in African countries is that there are lots of farms and agricultural industries in Ghana, but because most of them rely on very old-fashioned farming practices, like waiting for the rains to fall before you can irrigate the crops, or manually harvesting crops by just like sending humans on the farms instead of using some form of automation, as well as like working on the land by just getting humans to actually physically pop instead of using because most of the farming practices rely excessively on manual labor instead of some form of automation. We end up that ends up being a bottleneck and prevents us from actually performing longer. Prevents us from cultivating large areas of land that could help us to increase the production of these farms. And so we end up having a large piece of land, but then we only end up tilling just a small region of that land and planting even fewer crops, because we don't have enough manpower to work on these crops, because most of the young people end up going to the cities and looking for desk jobs instead of like staying in the villages and working on farms. And so because of that, our farms, even though they are very fertile, there is very little production from these farms, and we end up having to import all our crops and all of that. So in such a situation, having robots, getting robots to work on the farms to actually automate all these manual processes could definitely improve production, because we wouldn't need that much humans to manage these robots, just a few humans. But then having these fleets of robots work on the farm and do all of these things would end up enabling us to till much larger areas of the farm and help us to harvest more crops and store more of them and sell them on the markets, and reduce the amount of food we import into the country. And that could definitely help us to get enough food for ourselves, as well as export some of them to other countries and make enough money.
All right. So it's been exciting talking to you, Alphonsus. And I want us to take another short break where we'll get to watch more of your project. So we are back, and we've been talking about robotics, how Africa can use robotics to improve the economy, and we've been learning about Alphonsus's journey as a robotics engineer. Now I'm going to ask him, what is he currently working on? So, Alphonsus, what are you currently working on? And throughout your journey, what has been that like your best moment? Like the moment working on a particular robot that you never forgot, like an experience that has lingered in your heart.
So currently, since I started my PhD at the Robotics Institute, I'm mainly focusing on optimal control and planning techniques to enable robots to perform complex tasks in the home. So I'm still focusing on tasks in the home because it's very important to most people. And so most of my research focuses on developing algorithms to get robots to perform tasks like cooking and cleaning. And so when a human actually decides to cook a meal, we first think in terms of like, what is the end goal? What do we want this food to look like? And what are the ingredients we need to put together to perform this meal? And then we also think about like the skills we need to perform these tasks, like because we want to be able to cut food, to stir food, to fry food, and all of that stuff. And we don't just perform all of these tasks like anyhow. We end up deciding a sense of how to actually perform these tasks. And so getting the robot to figure out the right sequence of actions to take, as well as the right sets of low-level joint commands to send to the talks to perform these high-level tasks is mostly what I work on these days. And so that's my main focus. That's the main focus of my research, and hopefully for the next 5 years during my PhD, that's probably what I'm working on. And so with regards to my best moments were actually back at TAPS when I worked on these robots. So we not only just built these robots, but we actually had people with spinal injuries come over to the lab to use our robots. So there was this one time where we had a user session, called them user sessions. So we basically got a person with spinal injuries to come over to the lab and speak to the robot and get it to actually cook things and take things from the fridge and like set up basically just simulate regular lifestyle.
Okay.
And so we got this man to come over. He was I think Robert or something. And so he came over and he used the robot, and there was this point where we had to get the robot to actually open the fridge and get a bottle from the fridge and give it to him. And I wasn't sure it was going to work because prior to the user session, I tested it a couple of times and it worked like 50% of the time. And the other 50% was just knocking the fridge over and like hitting me and bruising. So I was scared it wasn't going to work. But then
it worked out.
He gave the voice command to the robot. Yeah, the robot actually opened the fridge and took the bottle and gave it to him. And he was actually very excited. He was like really happy, and my advisor was happy.
Excited if it was there.
Yeah.
All right. So
that was like one of my highlights.
Okay. So our time is fast spent, and so I'm going to ask you my last question. Right. So we have a lot of people watching you right now. We have a lot of people that are going to watch you in the future. Now, if there's somebody who is watching you, who is admiring your work and admires who you are today, what advice will you give to the person who wants to be a robotics engineer like yourself?
Yeah, I would say that you should probably robotics is not just being able to come and get a robot and to write the right programs to get a robot to do things. Even though that's what it looks like, but robotics is mainly more of a mindset of how to look at the world in terms of tools and in terms of parts you need to put together to build something. So it's more of like being resourceful, looking at the objects around you and figuring out how you can get them to interact with each other to perform a high-level system or to perform a high-level tasks. And so getting robots to actually being able to actually bring together these inanimate objects to get them to do animate things in the world is mainly what robotics is about. And that's something key. That's a key thing you should put in your mind, and you shouldn't let your apparent look of how your external environment is to dissuade you from doing things you really want to do. Because usually, if you have a big problem that you're trying to solve, it's usually easy to collapse under the heavy weight of the problem and think of like, how am I going to do this? How am I going to do that? But then the best way to actually think about the problem is using the first principle, not even trying to solve, and what exactly what's the simplest model of this problem that I can easily solve. And by thinking of the problem in terms of simple models, you can then keep making the models much more and more complex. And as you solve the simple models and go on to solve the more complex models, you realize that you're building up more more experience in actually solving this problem, and you're building up your capacity for solving these problems. And by solving these simple models and keep and increasing the complexity of these models as you go on, you realize that before you realize you've actually solved a bigger problem. And so usually when you face a problem, you think of the simplest model by which you can model the problem and solve that simple model, and then keep increasing the complexity. And that's the best way to solve difficult problems.
All right. Thank you so much, Alphonsus. It's been exciting having you today. I've learned so much. I actually thought you needed to do more mechanical engineering to be a robotics engineer, but today you've opened our eyes, and I've learned a lot from you, and it's exciting to talk to innovators from all over Africa and around the world. Thank you so much for joining me today, Alphonsus.
Yeah, thank you. And I like classical music as well. So
same here.
Pardon? If you're also interested in classical music, you should definitely send me song recommendations. I love Chopin and Vivaldi. At least for this week, I'm very much into Vivaldi this week. So if anyone has very good classical music recommendations, I forward them to Ida and she would send them to me.
Okay, thank you so much, Alphonsus. So it's been exciting today. We've been talking about robotics, and I can't wait to have the next session. So stay tuned. Don't forget to subscribe, and I'll see you next time. Love you. Bye.